It's chemistry and you are watching Chem Science.
In our earlier video, we have already learnt about the electrolysis of some molten ionic compounds, and in this video we'll learn about the electrolysis of some aqueous compounds, and along with that we'll see that how reactivity series affects the electrolysis of aqueous compounds. We'll also see the electrolysis of very dilute solutions or water, and then along with all this we will also learn how to write the ionic equations, or we can also call that as half equations. Let's revise some part of the electrolysis which we have already learnt in our earlier video. Is that in an electrolytic cell, the electrons flow from anode to the positive terminal of the battery when the anions gets discharged at anode, and after that when the cations gets discharged at the cathode, electrons flow from negative terminal of the battery to the cathode. And this is how the electrons flow in the external circuit. And in the electrolyte, the ions move towards the electrodes of its opposite charge, and this is how the circuit gets completed and the whole electrolysis process occurs. Now, when we talk about the electrolysis of aqueous compounds, that is when the compounds is dissolved in water. Say for example, if we have taken here as zinc bromide, so zinc and bromide ions are definitely present in the electrolyte, but along with that we have the ions from water, that is hydrogen ion and hydroxide ions also. Now we can see that there are two cations present in the electrolyte and two anions. Now out of these two, which one will get discharged at cathode, and after the two anions, which anion will get discharged at the anode? Now that depends on the position of the ion in the reactivity series. So let's understand that. Now here is the reactivity series. Now in this reactivity series, the ease of getting discharge increases down the reactivity series. That is, this less reactive metal ions will easily get discharged compared to the more reactive metals on the top of the reactivity series. Now let's understand why have we kept hydrogen in between. Now this is the only non-metal cation which can be discharged at the cathode. So if more reactive elements, metal ions, are present in the electrolyte, then compared to this highly reactive cations, hydrogen will preferably be get discharged at cathode and hydrogen gas will be formed. Now hydrogen is less reactive than these metals also, so in preference according to the reactivity series, hydrogen should get discharged at the cathode, but that depends on the concentration also. If we are taking highly concentrated solutions of these metals, then these metals may also get discharged at the cathode. Otherwise, if it's a dilute solution, then definitely hydrogen ion gets discharged at the cathode. But if such less reactive metals are present in the ionic form like copper, silver, gold or platinum, then these metals will easily get discharged compared to hydrogen or the other metals. And similar system works in the case of anions also. Now here are the polyatomic ions. Now if polyatomic ions are present in the electrolyte, in the aqueous solutions, they will never get discharged, but in preference hydroxide ion will get discharged, forming the oxygen molecules, that is oxygen gas will be formed at the anode. Now we'll learn the ionic equation of this and you will understand how hydroxide ion forms the oxygen gas at anode. But if halogens are present as an anion in the electrolyte, then preferably again halogen, that is halide ions, will be formed at anode, but again the discharge depends on the concentration definitely. If the solution is highly concentrated, then these ions will easily get discharged at anode. But if the solution is very dilute, then hydroxide ion will get discharged and oxygen is going to form as a product at the anode. I hope the discharge of the cations and anions preference is very clear, otherwise you can pause the video and re-understand it. And let's go ahead with the examples of electrolysis of aqueous solutions. Let's start with the example of the aqueous solution of NaCl, and if we take the concentrated aqueous solution of NaCl, then we in general language we call that as in brine. So electrolysis of brine means the electrolysis of concentrated NaCl solution. NaCl solution means aqueous form obviously. Now here, as we have already seen in our earlier video also, that the positively charged electrode is anode where the anions will get discharged, and negatively charged electrode is cathode where the cations will get discharged. Now here in an aqueous solution of NaCl, concentrated NaCl, again we have 4 ions, 2 cations and 2 anions. One is sodium ion, the second one is hydrogen ion, chloride ion and hydroxide ion. Now out of these 4 ions, we have already seen according to the reactivity series, the chloride ions will get discharged at the anode if it's a concentrated solution, and out of the 2 cations which is present, hydrogen ion will preferably be get discharged at cathode because these 2 ions are less reactive compared to its other ion. So at anode, chloride ion will get discharged and chloride ion will lose electrons, will move towards the positive terminal of the battery, forming the chlorine molecules, that is chlorine gas at anode. And this might be visible as the very faded green color fumes at anode. So this is one of the observation at anode, that is formation of a faded green color solution, that is the color of the chlorine gas. Now at cathode, hydrogen ion will get discharged and these hydrogen ions will accept electrons from the negative terminal of the battery and is going to form hydrogen gas. And these hydrogen gas might be visible at cathode in the form of the bubbles, colorless bubbles of the hydrogen gas. So an overall equation for the reaction in this electrolysis can be written as shown here, where we can see that along with the hydrogen gas and chlorine gas, NaOH is also formed as one of the product. And the reason being is that when hydrogen and chlorine gas is formed at cathode and at anode, NaOH, that is sodium ion and hydroxide ions, are left over in the electrolyte, forming NaOH aqueous solution, that is sodium hydroxide solution is formed in the electrolyte. So another product which is formed here is that sodium hydroxide solution. Now so in this electrolysis, 3 products are obtained, and that's the reason that industrially the electrolysis of brine is very important, because all the 3 products have a very wide use. And so the half equations at anode is 2 chloride ions gets oxidized to form the chlorine gas and 2 electrons are lost, and at cathode the 2 hydrogen ion gets discharged accepting the electrons from the terminal negative terminal, forming the hydrogen gas, and that undergoes reduction as the electrons are gained. Now, along with the electrolysis of aqueous solutions of NaCl, which is highly concentrated, that is brine solution, let's also understand the electrolysis of dilute NaCl solution, that is the water part is present more compared to the sodium and chloride ion. So let's understand what's the difference when the concentration changes. Now I had explained it in the earlier part of this video that if the solution is highly concentrated, then only the anion will get discharged at the anode. Otherwise, preferably hydroxide ion will get discharged. And because of this, the reaction will end up forming the oxygen gas. Now we will explain with the help of half equation that how the hydroxide ion forms the oxygen gas at anode. But before that, Let's see what happens at cathode. At cathode, hydrogen ion gets discharged, forming the hydrogen gas. And so, what is left over in the electrolyte is sodium ion and chloride ion, forming the NaCl solution only. So the electrolyte is not changing much, but what is happening is that the hydrogen and hydroxide ions are getting discharged. So the amount of sodium and chloride ions gets concentrated. And so the only change which happens in the electrolyte is that the solution becomes more and more concentrated and it becomes lesser in volume. So if NaCl is a dilute here, dilute NaCl solution, then the products will be NaCl solution only, but this will be concentrated NaCl along with the hydrogen and oxygen gases as the product. So at anode, half equation is 4 hydroxide ions ends up forming the oxygen molecules, that is oxygen gas, along with the water, and 4 electrons are discharged and passes to the positive terminal of the battery. And at cathode, the 2 hydrogen ions gets discharged, forming the hydrogen gas at cathode. So again, in this electrolysis, the observations will be the bubbles of oxygen being formed at anode and also the bubbles of hydrogen gas being formed at the cathode. This will be the 2 observations which will be seen. And in the electrolyte, as we have seen, the concentrated NaCl will be formed. So concentrated NaCl will be formed from the dilute NaCl solution. Now let's take an example, one more example of an aqueous solution, that is the concentrated solution of copper sulfate. So if copper sulfate is present in the electrolyte, then 2 cations, that is copper ion and hydrogen ion present, and along with that we have sulfate ion and hydroxide ion. Now which one will get discharged at cathode and at anode again depends on its position in the reactivity series, and you can go back, rewind and have a look at the reactivity series again to understand which ion is going to get discharged at anode and cathode. So at anode, rather than sulfate ions, hydroxide ions will get discharged, which in turn will form oxygen gas at the anode. But at cathode, copper ions will get discharged in place of hydrogen ion because copper is less reactive than hydrogen, and this in turn is going to form copper metal at cathode, accepting the electrons from the battery. And so the observation at anode will be the bubbles being formed for the oxygen gas, and at cathode there will be a red-brown deposit of the copper metal which will be seen because of the formation of the copper metal at cathode. And what is left in the electrolyte is the hydrogen ion and sulfate ion. So now what is the electrolyte changed to? It's going to change to the sulfuric acid because of the presence of hydrogen ion and sulfate ions. The overall equation can be written as this, where there are the 3 products, copper metal, oxygen gas and sulfuric acid in the aqueous form. And so here one more observation is the blue color of the electrolyte will be faded. So you can say that the blue color will change to colorless, or you can say it is going to fade to the lighter blue color because most of the copper will be used up, forming the sulfuric acid as one of the product, and sulfuric acid, as we know, is a colorless solution. So blue color can be, the observation can be written as blue color changes to colorless, or we can write the blue color fades. The at anode half equation will be hydroxide ions forming the oxygen gas, and at cathode the copper metal will be formed with the help of reduction. So oxidation occurs at anode and reduction occurs at the cathode. And in the next few videos we will also learn that the copper refining electrolytic method and electroplating will also be seen in these videos.